In this video, we will introduce the real numbers on the number line. The real numbers occupy the entire space on the line. Figure 1 is the number line that represents real numbers, which are rational and irrational numbers. The solid line represents all real numbers because they occupy the entire space. From the zero mark, the numbers expand infinitely in both directions, meaning that from the zero mark, which is the start point of each and every number line, the numbers will expand to the left infinitely or from the zero mark to the right infinitely. On the left side of the start point, which is zero, we have negative numbers. And on the right side from the start point, which is zero, we have positive numbers. There are no gaps in between the numbers. The arrowheads at the end points indicate to infinity, meaning no end. The numbers keep on expanding in both directions. Now, let us look at figure 1a. What I've done there, I've placed integers on the number line that represents rational and irrational numbers, which are real numbers. Now, these integers, each dot is assigned to a specific integer on the number line. As we know that the solid line represents rational and irrational numbers. But if that's the case, there are no gaps in between. Now, using these integers, you can see that there are no gaps in between the integers. Each and every rational and irrational number is represented. You are appreciated being with us. Welcome to the introduction of real numbers on a number line. So far, so good. Please take a like what we did, press the button, subscribe, like the video, and comment. Let's proceed. Let's look at rational and rational numbers in a more refined way on the line. I'm using the radicals in order to show how rational and irrational numbers behave on the number line. Let us look at the start point. What I've done here is that I've used the roots to represent each and every number on the number line. We are at -3, which is an integer. Now, each dot on this number line, each dot is assigned to a specific number, which is rational. Now, let us look at the dots on the number line. -3 is rational. -2.5 is rational. -2 is rational, and so forth. But let's focus on the radical signs. Radical signs, we have square roots and sets. Square roots are perfect squares and sets are not perfect. They are irrational numbers. On the line, as you can observe, those that do not have circles representing them are irrational numbers. Let's start from the zero mark. You can see that root 1 is 1. That's a rational. Root 2 and root 3 do not have the circles. It means they are irrational. You can see that root 2, if you use the calculator, you get 1,4212, etc. There is no recurring or there is no terminating decimal. If that is the case, like root 3, root 6, root 7, root 12, these are irrational numbers. I wanted to indicate to you what is the meaning of a rational and irrational number and how they behave on the number line. I hope it was clear and precise. Like the video, subscribe, share, and comment. Now, let us look at the positive direction on the number line. The positive direction means the increase will be from the left side to the right side. That will be the increase, the positive direction. And the negative direction will be the decrease from the right side to the left side. I hope you liked our video. Please subscribe, click the button, comment, and share. Keep well. Shabla. See you in the next video.